Okay, welcome back. Once again, we're solving 3x3 systems of linear equations. In the last video, we had looked at this first example here, so now we're going to pick up with the second example. Alright, so I'm going to go ahead and label my three equations 1, 2, and 3. And remember here, my goal is to eliminate one of the variables in two equations and then take another pair and eliminate the variables in those two equations. Here, all three equations have only two variables in them, so it looks slightly different than the last example. So I'm going to proceed by taking the first and the second equation, and since both of those have z in them, I'm going to eliminate the z. So just rewriting each equation. I'll have to multiply both equations in order to eliminate z here. So I'm going to multiply the first equation by positive 3 and the second equation by negative 4. By positive 4. I don't need to multiply by negative because the signs are already opposite. So that first equation is now 9x minus 12z equals negative 3, and the second 8y plus 12z equals 8. So I'm going to go ahead and add these two equations together. Notice that I do not have like terms, so I just rewrite them. 9x plus 8y equals 5. And this is my fourth equation. So I'm going to pair up my fourth equation with the third equation because both of those have x and y in them. Now I can decide to eliminate x or y first, whichever I would like. And in this case, I'm going to eliminate the y. So I'm going to multiply the top equation by 8. And the bottom equation by negative 3. Okay, so now I have 16x plus 24y equals 48. And negative 27x minus 24y equals negative 15. Now I can go ahead and add those two equations together. Which gives me negative 11x equals 33. I can go ahead and solve for x. And I have x is negative 3. Alright, so now I can take that x value and find the corresponding y value. I'm going to use the third equation to do that, but you can use either the third or the fourth equation because those both have x and y in them. Just substituting in the value for x that I found, negative 3. Just solving for y. So here I'll find that y is equal to 4, which means now I have x and y, so I could go ahead to either of the original equations and find z. So you could pick any equation that has z in it. So I pick the second equation, which has y and z. So I'm just going to substitute the value for y. And just go ahead and solve for z. So here I found z to be negative 2. which means the one point that these three planes intersecting is the point -3, 4, -2. Alright, let's take a look at the third and the fourth examples. These two examples show you some funky things that could happen when you have three equations with three variables. Let's begin here with the third example. Oh, nope, that is the second. Let's go back. Here we are. Here's our third example, and once again I'm going to label my equations 1, 2, and 3 just to help you keep track. And the most important thing that you can do here is take your time, be neat with your work, give yourself some space. So my plan here is to take the first and the second equation and eliminate x because the coefficients are opposite. Just rewriting each of those equations. And I could go ahead and add them together. X eliminates right away. There's my fourth equation. So I'll go ahead and take another two equations and also eliminate x. I'm choosing 2 and 3. I have to use equation 3 because I didn't use it before. And I can get away with just adding these two equations together because the coefficients for x are already opposites. Left with -3y minus 4z equals 4. And that is my fifth equation. Right, so I'll go ahead and take the fourth and the fifth equation together, make a system of two equations with two variables, and solve that. A problem within a problem. Just keeps happening. Sorry about that. So you might notice as I'm writing these out that both the y and the z's are both going to cancel. And when I do that, I have 0 on the left-hand side, but I have 12 on the other side, which is not a true statement. And since all the variables have been eliminated, but in the statement I'm left with is false, that means I have no solutions, or the empty set. Which just means that the three planes do not intersect at any point or any line. Right, so let's go on to the fourth example here. So once again, I'm labeling my equations 1, 2, and 3. They're a little bit cut off, but that's 1, 2, and 3. And I'm going to take two equations and eliminate one of the variables. I am choosing to take 1 and 2 and eliminate x. So I'll have to multiply the first equation in order to eliminate x. Right now I'm just rewriting both of them. Multiply the top equation by -2. Remember when you're multiplying by negative to change the signs to their opposite. Any sign error, tiniest mistake is going to throw off your whole solution. So now I can add these together, the x's cancel. I'm left with 2y, oh the z's cancel too, so 2y equals 6. That's my fourth equation. So if I continue with that same process, I want to pick another pair of equations and also eliminate x. I have to use the third equation since I haven't used that yet, so I'm going to pair up the first and the third. Just rewriting each of those. Last one here. Alright, so I've multiplied the top equation by -3 and I'm adding the equations together. once we do add that, we'll see the x's and the z's both cancel, and we're left with the same statement, well, not the same statement, but a similar statement, 3y equals 9. Now you might notice that this statement and this statement actually give us the same information. Both of them tell me what y is equal to. So if I go ahead and continue to solve the fourth equation, I will see that y is equal to 3. And the same thing with the fifth equation. When I solve that one, that also tells me that y is equal to 3. So I could use that information. I'm going to go to the first equation here and just substitute in that value of y. Now I still have an equation that's missing two variables, x and z. So I need another equation that has the variable x and z. So I'm going to go ahead and take the second equation, plug in the variable y, and I'm just labeling the last one. So that equation that I had before, I labeled number 6 because it's a new equation. Now I'm going to the second equation and plugging in the value for y. I just want to speed this up a little bit so I don't go past my limit. As I plugged in the value for y, simplified, I have a new equation, 2x minus 2z equals negative 6. Now I'm taking equations 6 and 7 and matching them up. Now I have to multiply the sixth equation by negative 2 so that the x cancels. Let me do that here, show you what that looks like. So just rewrote both of them here, and you could always pause this if I'm going a little bit too fast. Now I notice that the x and the z's both cancel, but here I have a true statement, 0 equals 0 is true, which means I have the case of infinite solutions. So in the case of infinite solutions, my solutions fall in either a plane or a line. So I have to be able to write that solution set. What we do is we usually choose z to be any real number. And then I'm going to write the variable for y and x in terms of z. So z is going to be any real number. I'm going to take any equation that has the x and z in it. I'm going to use equation 6 here, which has x and z. And I'm just going to rearrange that equation so that it's x equals. So I'm just adding z to both sides, and I know that x is equal to z plus 3. Now I need to do the same thing for y. Now in this example, y happens to be 3 always, but that doesn't always work, or that doesn't always occur. So just to show you what you would do in any case, take an equation that has x, y, and z in it. So I'm taking the first one, and I'm replacing the x, the expression for x, z plus 3, and I'm just going to solve this equation for y. So when I solve that equation for y, Alright, so again, I'm just solving this equation for y here. I had a small sign error because x was equal to z minus 3. I forgot the negative there, so I just made that change. And then I get y is equal to 3. So now I need to write my statement in a set builder notation. So the set of all x, y, z, such that x equals, and then write your expression for x equals z minus 3. And then write your expression for y equals 3, and write z will be any real number. Alright, hope you enjoyed this video. Take a look at the examples in your text for more support.